All right, hello. Good afternoon. Welcome to B-Sides Las Vegas. You are in breaking ground. This talk is the Northern Virginia Shuffle, lateral movement and other creative steps attackers take in AWS cloud environments and how to detect them. Let's get started. Please welcome Philippe Proteus.
Thank you, everybody. Thank you for coming for my talk. So, my name is Felipe, as you heard from Piers, and my nickname is Proteus. So, just my mom called Felipe, so you can call Proteus wherever you find me, or whenever. So, a little bit about me. I have at least 10 years of experience in security in general. I'm a proud father of a girl. I'm also a blue team instructor back in Brazil. And I'm a security researcher at TNT Security. TNT Security is a startup company based focused in cloud security and third-party risk management. And as my role as security researcher, part of my job is Googling around, reading documentations, and writing POCs to test vulnerabilities and this kind of stuff. And sometimes we help our clients with questions. So I was there one day, Googling around, reading docs, and one of our clients came to us and asking about his network diagram on AWS. And he was doing all kinds of nasty stuff. He was doing things like VPC peering between dev and prod environments, cross accounts between dev and prod environments. And I said, no, you're doing something really nasty here. You shouldn't do this, because there's the problem of lateral movement. And he says, what? And yeah. And then I explained him. And then something popped in my mind. I just realized that cloud security is more complex than on-premise security. And I know that's a bold statement, but I do have an analogy or a metaphor to explain that. So, by the title of this talk, when I submitted this talk to BSides, I was thinking, well, what things walk laterally and doesn't walk laterally, so I can get a theme for my talk. And the only thing that I could think was crabs. But I don't like crabs. I guess nobody likes crabs. So I was talking to my boss, Sierra, and he told me about this kind of dancing. It's called Texas Shuffle. And for those who doesn't know which Texas Shuffle kind of dancing style is something like this. Seems nice, right? But I'm a Brazilian, and I'm from Rio de Janeiro, actually. So I have to bring something for you guys to do a contrast between the Texas Shuffle. And the dancing that I brought here today is something that we call passinho. It's like a Brazilian funk. So it's kind of like this. Yeah, two different dancing styles with their respective differences. And we'll get a little bit more on this later. But just keep those dancing in mind. So, when we talk about lateral movements and possibilities of lateral movements, how many of you guys already did a pen test on-premise networks? How long did you guys take to get a domain admin? More than a day or more than 2 days? Usually, you just pivot pretty fast between all the networks, find the domain admin, get the credentials, and become a domain administrator, right? So this can also be done on AWS. But on AWS, you can have separate accounts. So you can have account A and account B. And for do this kind of things in AWS, must have to be a VPC peering between those accounts and those VPCs, right? So when an attacker, usually an attacker doesn't land when their objective is. So he has to move laterally, right? So if he hacked an instance on the VPC A, he can find out on other networks and move laterally until the VPC B, and so on. This thing in AWS we call data plane. And data plane is where your data lives, actually. But on cloud, we also have another plane that's called the control plane. And the control plane is like, it's all the APIs that you call to make requests to your cloud provider. For example, in AWS, you call it the control plane to create a new VPC, to create EC2 instance, or S3 bucket, things like that. And the thing with the data plane, to get in, you just have to get something exposed, like an IP address or things like that. But just to get in on the control plane, you're gonna need a credential, or a login password, or AWS access keys, and so on. In the control plane, you have entities like users, roles, groups, and things like that. So how do you move laterally on the control plane? So here you have a role in account A, and this role can assume another role, the role 2, in the same account. But the thing is, the attacker who got the role 1, he could also exec and create an instance on the VPC A, and then he can jump from the control plane to the data plane. And if the attacker got first hacked a EC2 instance, and he find out that his EC2 instance has a role attached to it, he can assume that role and jump to the control plane. And from there, he can also find out another networks, another accounts in AWS, and jump from account A to account B. And he could also, from the same EC2 instance, if he find out another account, he can jump from the EC2 instance in account A to another role in account B. So you can pretty much see that these things getting even more complex than on-premise network, right? And even though the same attacker who has a role in account B, he can also exec and execute, create an instance on VPC on account B. So it's really, really mess, right? So just to bring that comparison between those dances, and I promise to my sister-in-law to not make comparisons between dances because that's not something that you should do, but we can compare features between those dances. So who thought that the Brazilian funk would be more hard to learn? Who thought that the Brazilian funk would be harder to learn than Texas Shuffle? Anyone? Yeah. But the thing is, the Brazilian funk, it's only fast. He was dancing by himself. Fast moves, yeah, but dancing by himself. The Texas Shuffle, he has to interact, there has interaction between the partners. So they also can dance by themselves. If you watch the video clip again, they also dance separated between them, but they also have to coordinate the weights and balance between them. So there's much more aspects and complexity in Texas Shuffle than Brazilian Passinho. So the Texas Shuffle should be our cloud environment. The comparison between data planing, control planing, and the balancing between those. So, I just copied from the Cupid Shuffle some steps to introduce you to the lateral movements. So everybody knows that music is like to the left, to the left, to the right, now, kick, now, walking by yourself. It's a really anthem, at least through cruisers and things like that, and marriages. So when we talk about lateral movements on the data plane, between two EC2 instances on different VPCs connected by a VPC peering, some things doesn't work as expected. For example, ARP protocol doesn't work as expected because in AWS you don't have the broadcast. So if you enter in console and do ARP-A, you won't see any machine, just your machine and the router. So there is no easy ways for an attacker to find out which other networks are connected to this account. So the solution for this is to do a network scan. So he can scan the whole range, the whole /8 range. It's noisy but effective. It's gonna, if the blue team of that company has some flow logs and things like that, you're gonna catch him. But it's effective for the attacker. So he could find a new instance on other VPCs and on other subnetworks, and then hack it their way into this new instance. Another kind of lateral movement is when the attacker came from the EC2, he hacked the EC2 instance, for example, or a Lambda, or a ECS, or a batch job. There's any kind of data plane things that can assume a role. And he can just get those information, enter on this machine. If there is a role attached to it, he can store these credentials and jump to the control plane. By doing this, something pretty much like this. So the attacker lands on this EC2 instance. So he does a STS get caller identity to find out which role he has. And now you can see that he has the 10T EC2 role. So he's going to dump credentials to jump to the control plane. By doing this, he's using the metadata. Metadata is a service from AWS who gives a lot of information about the role that the EC2 instance has, and credentials, and information about that instance. So here the attack would be able to get the credentials, and then he can use some tools to post-exploration that. One of the tools is the Pacu. It's an open source AWS exploitation framework developed by the Reno security guys. So if you guys don't know this tool, just download and play around. It's a really good tool. Has some defects, I don't know how to say that, but it's a pretty good tool in general. So there's another kind of lateral movement that I call here step down. And that means when an attacker is able to get any kind of credentials or access keys or login and password without MFA from a user, or perhaps with MFA, with phishing, the attacker gets this credential, connects to the control plane, and if he finds out there is a VPC there, and he wants to see what else has in that VPC, he doesn't have enough permissions to walk around that networks, well, he creates a new EC2 instance, then he sends a command for that EC2 instance, for example, using the SSM or loading the data inside the user data for that EC2 instance, and then he can jump to that EC2 instance and execute code. Here, in this example, the attacker sends an SSM send command to an instance and creating a reverse shell for here attacker IP address on port 31.30.37. So, and when we talk about lateral movements on the control plane, things are a little bit more trickier than on the data plane, right? So, here we have 3 accounts. Let's assume that we have 3 accounts, account A, account B, and account C. If the attacker gets a credential in account A, and the account B has this following policy here, that says that the principal is AWS, any entity coming from the account A, so a user is an entity from account A, can assume role. So an attacker would be able to jump from the account A to the account B without no problem and assume this role. But when you think an attacker got access to account B and he wants to jump to account C, you're tempting to think that this policy must be enough for him to jump between accounts, from account B to account C. But that's not true, because when it happens, when the attacker assumes the role from account A to account B, and then try to assume a role in account C, he's not actually coming from the account B. is coming from account A, and this policy won't work. The true policy that has to work, it's something like this. It has to be an assumed role from account B with a role. And when you assume a role in your account, usually you put a value, like testing or your name, your username, something like that. And it also has to happen here in the policy on account C. I will be pretty honest with you guys. I've never seen this in any of our clients, nothing like that. So I suppose not work like this. And the thing is that thing that we call assume a role A, assume a role on B, and assume a role on C, it's called role chaining. And this has a hard limit of 1 hour from AWS. So even though if you could be able to assume a role on B and assume a role on C, the maximum time that you can assume that role is for 1 hour. That's not much a big problem because all the APIs from the AWS are really well documented, and an attacker might script their way and creating persistency and backdoors all over. So this role chaining is not a big problem. But an attacker can be creative, right? And usually they are. So there's another kind of movement that I call now kick, because when this policy comes from the account B, the account B is the root, an entity on an account B, right? So if the attacker has the action, the ability to create an EC2 instance, he would be able, silent, I kill you, share the picture, whatever. All right, so when an account A, when an attacker on account A would be able to create an EC2 instance on the same account, the EC2 instance is an entity on this account. So he would be able to assume a role, give a permission to his EC2 instance to assume a role on account B, and he jumps to account B as an entity assumed by account A. But he also could be able to create a new instance on account B, and then jump to account B, and then assume a role on account C. And it would be something like this. So he went to the control plane, down to the data plane, back to the control plane, down to the data plane, and then back to the control plane again until he reached the account C. So that occurs because AWS doesn't treat EC2 instance using roles as a role chaining thing. So there's no limit. There's upper limit to up to 12 hours, but it's a way to bypass that. So what are the attacker requirements to make this thing work? So he has to have enough privilege on AWS. So he must have STS assume role and preferably resource star. That means that he can assume a role in any resource. And he also has to know a related account on the same organization. So this can be found in CloudTrail, IAM policies, and through OSINT. Sometimes you go to the GitHub account from that organizations and find out they have like 3 or 4 other accounts with account numbers shared there, because account numbers are not really a secret, right? So you can share. It's not supposed to, but you can. And they also has to know an ARN of a role to assume in the new account. So when you do an STS assume role, you have to know the ARN the ARN of the role that you assume in the new account. This can be brute forced because usually it's created by humans. So you can brute force like a role like account number, role admin, administrator, and things like that. But there's a special case because when it's coming from the master account, there's a special case for that. So let's talk a little bit about privilege escalation. Privilege escalation is a set of actions that allows a principal to increase their privilege. For instance, you can imagine a user with a really low privilege, but with enough actions to improve his actions, his capabilities. There was a great research by the late Spencer Gitzen from Reno Security Labs, and he found out at least 28 no privilege escalation techniques. And there was a really new one released by Spooker Labs today in his talk, if you guys saw it on App Stream, about App Stream. And there's even more possibilities because with combinations with EIM pass role. This is an action on AWS. And there's a really good research by Noah and Derham. And when he finds out new kind of privilege escalations combining EIM pass role and other actions from AWS. But the thing is, not all privilege escalations are created equal. Let's take some examples. Not all the techniques have the same effectiveness and allow you to become an administrator ASAP. So here we have two techniques. The first one is the IAM create policy version that allows you to become a system administrator as just creating a new policy version and becoming an administrator, right? But there is another technique called set default policy version that depends on you have another policy version that allows you to become administrator earlier. So if you have the policy version V1 here that allows you to set default policy version, but the policy version V0 doesn't allow you to become a system administrator, this technique of privilege escalation might give you some more permissions, the permissions of the version 0, but not become a system administrator, right? So there is a tool that's called cloud explaining. Anyone have ever used it? Yeah, it's a good tool. It was created by Kinner McQuaid. He was working on Salesforce at that time and released this tool on April 30, 2020. And the current version is 0.50. But the good thing about this tool is that it downloads your IAM policies, inline policies, custom policies, and AWS policies, and analyze those policies looking for privilege escalation techniques, data exfiltration, possibilities of data exfiltrations, resource exposure, credential exposure, and infrastructure modification. So you generate this kind of report, a pretty HTML report with those techniques and these graph bars and things like that. So it turns out it's pretty easy to analyze privilege escalations with this tool. So another attacker requirement is to know the account ID of a related account on the same organization, right? So this can be found on CloudTrail, and here we have an example of a CloudTrail of EM role getting AWS API call, disclosing an account ID. And it can also be found in AIM policies, because if you have cross-account policies, and those cross-accounts has to have the number of the account to the destination, right? So you can find out new numbers there, and also through OSINT, as the example of the GitHub that I gave you guys before. So, and the third thing, and the third trick actually, if the targets use AWS organizations or AWS Control Tower, the role that AWS organization creates and Control Tower creates on the child accounts on AWS, it's a well-known name. It's called Organization Account Access Roles. And for the Control Tower is an AWS Control Tower execution. And they have admin privileges in the child accounts by default. So if an attacker gets access to the master account, he will know by just doing an organization list the number of the accounts he has, and he can also jump from his account, from the master account to any other account because he already knows the roles for that, like organization access or AWS Control Tower. Even though the AWS Control Tower execution role has two principles. One is defining the services, so Control Tower can also assume a role on your account. But the thing is, there's a principle here from the master account, as any entity on the master account can also assume this role. So if an attacker gets access to a master account, it's done. Game over. So let's run some true scenarios on AWS, some usually patterns that people do on AWS. So the first pattern is called hub and spoke. when you have multiple accounts, each account for a production, account for a development, staging, and so on, and a shared account who shares database and things like that. So as an AWS administrator, you can do some kind of mistakes. For example, creating an EC2 instance on the shared VPC with two ENIs, one routing to account A and another one routing to account C. What that means? That means that if an attacker could hack any account in any EC2 instance in account A, find out there is an instance on the shared VPCs, hack the shared VPCs, he will see that you have two NIs, and the another one will allow him to jump to account C. And the other things that you can do on this kind of scenario is do VPC peering. So if you do VPC peering between account A to account B to account C, you are basically making your network flat. And there is another pattern that we call CI/CD account. It's basically like this. You have a master account and you have a CI/CD account. And this CI/CD do deploy for dev, for stage, and for prod accounts. And the master can access the dev and the stage. A user in a master can access the dev and stage, but he can't usually access the prod account. What an administrator can do to break this pattern is create a cross account between the dev and the CI/CD, the backwards, you see? And when he do that, the user might be able to get a credential in dev, then jump to CI/CD, and then jump to prod. Just by assuming role between control planes. So in order to help our customers and find out really easy ways to find out privilege escalate, lateral movements between accounts and those kind of things, we tested a lot of tools, but none of did what we expected them to do. So it's time to build our own, right? We tested PMapper from NCC groups. We tested AWS PX from F-Secure Labs, and Cloud Mapper from Duo Labs, and a lot of tools, but none of them did what we expected them to do easily, at least. So we had some requirements, right? So we should use open source and free tools. We should download automatically through the AWS APIs all the necessary info to plot the graph, also from the control plane and data plane, and also has to have a query language to allow raising alerts automatically. So we decided to use Gremlin as a graph database query language, and for doing this, we are using Apache Tinkerpop behind. We are also using Cloud Splaining to allow us to log in multiple accounts and download all the information, and also some splitter scripts to download information about the data plane things that we needed to our project. And we decided to use D3.js. That's an amazing graph library. Pretty easy to make things on that. So our model, how we model that? Well, all the squares that you guys saw on the presentation are things from the data plane, like EC2 instance, lambdas, ECS, or anything like that. And everything that was circle is from one account. And the colors makes the difference between accounts. And also we have an arrow with a directional relationship. And so it's demo time. The thing is, this tool has no name yet, so vote on Twitter. I just make a poll this morning, and you guys have only these 4 options of names, sorry. But yeah, that's what the Twitter allow me to put on percentage as options. And please vote, and we will publish the tool as soon as possible. So it's demo time. Right. Here. This is the interface of our no name yet tool, as you can see right here on the left. And we based this interface in a project from the GitHub, the project called GraphXP, from a random guy that I don't know him, but it was kind of, we just modified a little bit the code to make this work. He has a JavaScript Gremlin carried interface with the Apache Tinkerpop. So just to grab, I already loaded all the information from the AWS, and just click search, you'll be able to graph this information. So you can see rounds are control plane stuff, squares are data plane stuff. You can zoom in, zoom out, pan for the left, to the right. But the data that I show you guys here, it's like a mock-up data from based on one of our clients who has hacked. So the attacker was able to grab his credentials, create an EC2 instance, and just do data mining. But the thing is, if the attacker would be able to, it was a bot, so he was not smart enough to find out lateral movements. But if it was a person, if it was a real attacker, and he could be able to find out lateral movements, our client would be screwed. And I show you guys why. Here, you can move the pieces around, and this is the user who got the credential leaked, and the attacker was able to create an EC2 instance. And this EC2 instance was in the master account, so he would be able to jump to all those other 4 accounts that he has. The green, the blue, the orange, and the light orange accounts. And this client also has a VPC peering between other accounts, the orange account. So this instance, he would be able to perhaps hack this instance and then jump to another instance and then also become a system administrator, because this instance here was on a private subnetwork, but he has the administration role attached to it. And the easiest way to analyze things like that is to look for clusters, like this one and this one. The second cluster is from his CI/CD, so there is an account who deploy here and an account who deploy here, and there is a EC2 instance with Jenkins here to deploy for those accounts. And things like that are usually lambdas with a role, because lambdas has a role attached to it. And they're like sparse, they are not connected to the whole graph. And you could also use a filter, like privilege escalation here, and you would see that you fade out or raise the transparency the other nodes. And there is a possibility of privilege escalation here from between those 2 rows. And if you click on the edge, you'd be able to see that there is a label, edge for privilege escalation with the create policy version. So you can also carry information between those nodes. So we have some future work to do, or our to-do list, as we used to call. So one thing that we want to put on this tool is to be able to evaluate restrictions of all privilege escalation techniques, because, for example, the example that I said before, there are some kinds of the privilege escalations that needs EC2 instance, that needs lambdas. If there is no role in that account, with the permissions enough to that lambda, will not be a privilege escalation at all. You won't be able to get more actions. We also would like to add support for other resources like S3 and RDS, support for resource-based policies, and a better visualization and filtering for this tool. And we can draw some conclusions from here. Well, first of all, is try to apply the least privileged IAM role permissions. And I know that's easier said than done. But you can abuse of SCPs and IAM boundaries to limit most of what an attacker can do in your network. And never use a resource star, because when you do resource star, you can do those actions that it has permissions in any resource. So a good thing would be restrict the kind of resources that that attacker can make moves. So other thing is don't run local workloads in your master account. So your master account in AWS from organizations should be empty as much as possible. Don't cross any account to the master. So that case on the CI/CD, when there is a connection between the CI/CD and the dev back to CI/CD. If you do this kind of things, you're allowing privilege escalation. You're allowing lateral movements. And always review all your trusted cross-account policies. And for sure, segment your network and accounts as much as possible. So, thank you guys. That's all I have for you today. Any questions? The code will be released on GitHub/TNT-Security, and hopefully soon. Any questions?
I've got the microphone here. If anybody wants to have a question, just raise your hand and I'll try to hand it off. I'll ask a quick question. A lot of the stuff you talked about today, does it also apply to other cloud providers like Azure, Google Compute Platform?
The lateral movement, yeah. It's possible, on all other cloud providers. But the things like AWS organizations are basically on AWS.
Thank you.
Thank you very much.